So today's topic is analysis of stopping distance. This PDF, this PDF page I have taken from the your Khanna Jastu book. Okay, in Khanna Jastu book, this analysis of stopping distance is mentioned properly, and I will give this page two-page to all of you. I think after reading these two-page, you will also get the same information. Whatever we'll discuss today, you will get the same thing from this two-page. Very simple way. All the things are written here, and just the analysis of side distance, basic analysis through which or from where we are started our study. So analysis of stopping distance, the already mentioned all the things, just I will dictate here. The analysis of stopping distance, the stopping distance of a vehicle is the sum of stopping distance of a vehicle, okay, is the sum of number one, the distance traveled by the vehicle during the total reaction time known as lag distance. The distance traveled by the vehicle during the total reaction time. Already we have some idea about reaction time, and under total reaction time or during this total reaction time of our human being, reaction time is directly involved with us. This and this total reaction time, the distance, but I is different thing, it's me, it's a different thing, and vehicle, operation of vehicle is different thing, because vehicle is operating by mechanical things and I am human being. So due to reaction time or due to decision making, such kind of activity, normally this during this reaction time, vehicle already is going or he is doing his its work, vehicle. So that's why for this reason vehicle will travel little distance, or the distance which is called as lag distance, the distance traveled by the vehicle during the total reaction time known as lag distance. Number two, the distance traveled by the vehicle after the application of the brakes. Okay, immediately or suddenly if we apply the brake for stopping our vehicle, it is not possible to stop at the certainly after applying the brake instantly, it is not possible to stop the vehicle. After applying the brake, normally vehicles take some time or it travels some distance, then it will be stopped. Okay, and now the thing is important to me, the distance traveled by the vehicle after the application of the brakes to a stop position, which is known as the braking distance. Okay, so after application of the brake and before stopping the actual completely stopping the vehicle, this distance is called the braking distance. One is lag distance, another is braking distance. Lag distance depends on your reaction time, and the braking distance is depends on the application of brake and actually practically the stopping of the vehicle. This distance is called braking distance. So these two distances are important for analysis of stopping distance. Now in a details way, if we study the lag distance during the total reaction time or PIEV, already we have studied that what is PIEV, perception, interaction, emotion and volition. This PIEV time, that is total reaction time, the vehicle may be assumed to be proceed forward with a uniform speed at which the vehicle has been moving, and this speed may be taken as the design speed. Again I am repeating, during the total reaction time, the reaction time which is directly involved to our human being, during this total reaction time or P theory time, the vehicle may be assumed to proceed forward with a uniform speed at which the vehicle has been moving, and this speed may be taken as the design speed. Okay, design speed is the speed which is allowed for any particular road. Okay, that is design speed. For the condition, based on the condition of the road, based on the geometry of the road, okay, based on the environment, based on the terrain, the nature of the earth surface, nature of the valley, nature of any or the condition of the traffic, we are as an engineer, traffic engineer also normally belongs to the civil engineer. So we as an engineer, we are designed some speed for particular zone, particular road, that is called the design speed. Okay, and with this design speed, when suppose I have to stop my vehicle due to some obstruction in front of my vehicle, my reaction is started, and during this reaction time, normally the vehicle also at the simultaneously vehicle also will go with some design speed, okay, which is designed for the particular road. Okay, forward with a uniform speed at which the vehicle has been moving, and this speed may be taken as a design speed. If V is the design speed, V can be denoted as a speed in meter per second, and T is the total reaction time of the driver in seconds, then the lag distance will be V into T meters. Okay, so V is the speed, unit is meter per second, and T is the time in seconds. So if we multiply with V and T, then the Vt is the distance, or it would be the lag distance, or it would be defined as the lag distance. Okay, if the design speed is V km per hour, then the lag distance works out to V into, to convert into kilometer per seconds, sorry, in kilometer per hour. To convert into meter per seconds, we have to multiply V into 1000 by 3600. Therefore, this T equals to 0.278 Vt meters. Okay, the total reaction time of driver depends on variety of factors and value of 2.5 seconds. It is considered reasonable for most situations. So total reaction time normally during calculation or during our solving numerical problem, we will consider 2.5 seconds total reaction time. Okay, 2.5 seconds. It is considered reasonable for most situations. The IRC has also recommended the value of reaction time T equals to 2.5 seconds for calculation for stopping distance. So normally for a average human being, this time is appropriate for calculating reaction time, or considered as a reaction time. 2.5, during 2.5 seconds we can take a decision in some, suppose in a hot situations, or suppose in a dangerous situation, we can take decision within 2.5 seconds. Our brain can take decision in 2.5 seconds. Okay, so as per such based on such conditions, IRC consider the total reaction time should be 2.5 seconds. And in our solving numerical problem also, we will take this 2.5 seconds as a reaction time. This is important to us. Even in objective type question may ask this question, the total reaction time should be 2.5 seconds. Now this is the lag distance. So simply lag distance is V into T. If V in kilometer per hour, then we can also we can convert as a 0.278 Vt meters. So if in any problem it is mentioned, suppose 80 km per hour, then simply we have to multiply with 0.278 with this 80, then easily we can calculate the meter in meters. Okay, next is braking distance after lag distance. Okay, braking distance. Braking distance. Now, the coefficient of friction F depends on several factors such as the type of condition of the pavement surface and tire. Also, the value of F decreases with increased speed. IRC recommends the following F values for design. So, coefficient of friction already we have studied in earlier chapter. That is, there is in road surface characteristics, there is coefficient of friction. Okay, coefficient of friction between tire and the road surface or pavement surface, and this is depends on number of factors like condition of the tire, condition of the road surface, condition of the brake, application of brake. Lots of factors are involved in this coefficient of friction. Though IRC recommends some coefficient of friction values based on design speed. Suppose when your speed in 20 to 30 km per hour, your longitudinal coefficient of friction F would be 0.4. When your speed in 40 km per hour, your longitudinal coefficient of friction would be 0.38. When your speed in 50 km per hour, your longitudinal coefficient of friction would be 0.37. When your speed is 60, the value would be 0.36. When your speed is 65, the value would be 0.36. When 80, 0.35. When 100, 0.35. So almost 0.35 to 0.4 we can take as a coefficient of friction. Normally in our exams some liberties there, some liberties are there. What type of liberties? Like suppose question in question maybe it is said, it is asked that, or it is mentioned that your speed of the vehicle is 60 km per hour, but I forgot the value, all these values, these divisions 0.4, 0.38, 0.37, 0.36. I forgot all the things. So my suggestion is you can take 0.4 all the time, no problem, no harm is there, because very little difference is there. You can see in 100 km this longitudinal coefficient of friction is 0.35, but in 20 to 30, if your speed of the vehicle is 20 to 30, this value is 0.4. so difference is only 0.05. so you can take in all the cases 0.4. it is no problem, and you can solve any numerical questions using this value 0.4 value as a coefficient of friction to calculate the braking distance. Next is assuming a level load. The braking distance may be obtained by equating the work done in stopping the vehicle and kinetic energy. Okay, let's see. If F is the maximum frictional force developed and the braking distance is L, okay, then the work done, braking distance already we know, the braking distance is the application of the brake and stopping, the actual stopping of the vehicle. During this time, traveling distance by the vehicle, that is braking distance. So if F is the maximum frictional force developed and braking distance is L, then work done against friction force in stopping the vehicle is F into L, okay, equals to small f W into L, where W is the total weight of the vehicle, okay, and capital F is the maximum frictional force developed, and small f is the coefficient of friction, okay. So small f is coefficient of friction. This is the maximum frictional force into L. L is the braking distance, equals to small f is the coefficient of friction, W is the total weight of the vehicle, again L is the braking distance. So normally F this maximum frictional force we can break into coefficient of friction into weight of the vehicle. The kinetic energy at the design speed of v meter per second will be, because this design speed, suppose this in any design speed we can define as small v. So that's why here written as the for derivation, the kinetic energy at the design speed of v meter per second will be half into mv square equals to wv square by 2g. Okay, hence the kinetic energy at the design speed, this is the expression of kinetic energy, half into m is to v square. And if we break into if we break again, then w into v square by 2g, mass converted to the weight by g. Okay, weight by gravitational force, so wv square by 2g, and this is the equation of kinetic energy. Okay, when kinetic energy at the design speed of v meter per second, this equation will come half into mv square. Hence again, so F into W into L equals to wv square by 2g, because this is actually the work done against friction force, FWL. This is the work done against the friction force, equals to wv square by 2g, or L equals to v square by 2gf. Now L is the braking distance, and braking distance can be expressed as v square by 2gf. P is the speed of vehicle meter per second, f is the design coefficient of friction. This value can be taken 0.4 to 0.35 depending on speed from 30 to 80 km. But my suggestion is, if you forgot to put the actual value of coefficient of friction, you can take 0.4 instead of for any case for any speed 0.4 can be taken the design coefficient of friction value. G is the acceleration due to gravity, 9.8 meter per second square. Stopping distance, therefore stopping distance, actually the stopping side distance or basic side distance or stopping distance, we can say is equals to lag distance plus braking distance. And lag distance, already we have seen, lag distance is the v into t. This is the lag distance. Okay, 0.2 in your value in kilometer per hour, 0.278 vt. But normally if your value in meters, so this v into t is the your lag distance. So v into t is the lag distance, and braking distance is the v square by 2gf. Okay, now completely side distance or stopping side distance in meter equals to vt plus v square by 2gf. If speed is v kilometer per hour, stopping distance would be 0.278 vt plus v square by 2gf. G is the 9.81. That's why they have converted on v, also v in kilometer per hour. That's why after converting they are getting 254 a, v square by 254. Okay, v value if we take in meter, then this formula will be used. This will be used if we take side distance in meter, and if we take v in kilometer per hour, then this formula will be used for calculation of side distance of the vehicle. This v value, suppose in your question velocity of the vehicle is 80 km per hour, so directly we can put 80 instead of this v, 80. But in your question it is mentioned that the speed of the vehicle is in meter per second, then only we can put the v value here. Then this equation will be used for calculation. But when in your question the speed of the vehicle is given in kilometer per hour, only then this equation will be used for side distance calculation. But also you can convert your speed from kilometer per hour to meter per second. But my suggestion is you are not yet 5th standard students or 6th standard student. Always you should use this equation when the question is mentioned that in the speed of the vehicle is kilometer per hour. You should use this equation, and when in question it is mentioned the speed of the vehicle in meter, then you should use this equation. Okay, so for today I think only 1 2 3 4 5 6 students, so I should stop here because lots of things are here. If we go with F already this F value, friction value already given in IRC, but you can use suppose 1.5. I think 1.5 value, the F value is 1.5 normally. So, sorry 0.4 to 0.35. okay, this F value. This value also given in IRC, but in your exam Indian Road Congress the IRC the code is not allowed in the exam. Okay, but this value is a common value 0.4. You can take 0.4 F value for calculating side distance. Okay, I'll stop here. Just wait. I'm taking the attendance. Just wait. Just let me check. Okay, I am stopping here because very late student. Thank you. You can leave.